Okay, let's look at using the first derivative test to find the maxes, mins, and then the intervals of increasing and decreasing of a function. So notice we're given a function here, and I'm going to go ahead and do this with the calculator because you can do it by hand, but it's going to drastically speed it up if you do it with the calculator, especially when we get into the actual first derivative test where we're testing values. So I'm going to go ahead and enter my function, and I'm going to say control var because I want to store it, and I'm going to store it as f of x. Next, well, I need to get the derivative. So again, you could do this by hand, but we're going to put it right into the calculator, do it nice and fast. And remember, I went menu, calculus, derivative, and now we have our derivative. So now I'm going to go ahead and store that as g of x. All right, so we got that stored. Now, if we want to figure out our maxes and mins, well, we first need to know the points where we have a max and min, right? And the way to find that is where whenever the slope of the tangent line is 0, that means we're going to have a max or a min because we have whenever the slope of the tangent line is 0, it creates well, it's because of a maximum or minimum in the graph. All right, so I'm going to go right ahead with the calculator just to save time. I'm going to say algebra solve. Now, since I have the derivative stored as g of x, I'm going to put that equal to 0, and then I'm going to say comma x. Okay, so now I got two solutions. I got x equals 1 or x equals 3. So at this point, I'm going to record some of my information here. But before I do that, I have the x values, but I need the y values, right? In order to get the y values, you got to think going back to the original, right? Because we really want that actual point on the original graph or the original function, which is f of x. So I put in 1, I get 5, and I say f of 3, and that gives me 1. So at this point, I'm going to record all this information before I do the rest of the problem. So we have our derivative, f prime of x equals 3x squared minus 12x plus 9. And remember, when we solved for x, we got x equals 1, and then we also got x equals 3. We went back and put those points in. We got, well, let's check with our calculator. We got 1 comma 5 and 3 comma 1. So, you can, just think about which one has the higher y value. In this case, if there's only two maxes and mins, then one has to be a max and one has to be a min. So if I'm thinking about that, well, we have 1 comma 5, right? 1 comma 5, and then we have 3 comma 1. Well, the higher y value is 5, so that's going to be our max, and then our min is going to be at 3 comma 1. Okay, now, so actually I've done the first part of the problem, but in order to find the intervals of increasing and decreasing, I'm going to set up a little number line. And here's where we actually do the first derivative test. So I'm going to say, all right, well, at 1 and 3 are my maxes and mins. So I'm going to say at x equals 1 and x equals 3, those are my maxes and mins, right? So because this is a polynomial, it's just going to alternate. But all you have to do, right, is I want to test numbers in between our maxes and mins. So I could test 0, test 2, and we'll test 4. So I'm going to go ahead and do that with the calculator because it's going to greatly speed up the process, right? Remember, I saved my derivative as g of x, so I can just go ahead and input 0. Now I got 9. So that's a positive number. So what does that mean? Well, that means the graph is increasing from negative infinity to 1. Okay, now in a polynomial like this where it's there's no fraction or anything, it's going to alternate. But let's just check to make sure because it's good to kind of check our work here. So if I input 2, I'm going to get a negative number. And if I input 4, I'm going to get a positive number. So I know that this diagram here is good, and now I can write my final answer for where f of x is increasing and decreasing. So I'm going to go back over to my work here, and I'm going to say, well, f of x is increasing on, and we're going to write the intervals of x, right? Because what we're really saying is y, or the graph is going up from negative infinity to 1, and then again from 3 to infinity. And then f of x is decreasing on, well, just from 1 to 3, right? So now we're done with this first problem. We have our maxes and mins, and we have our intervals of increasing and decreasing. So we're good here with this problem. Okay, let's take a look at one where it doesn't just alternate here, and it's a little bit trickier. Okay, so now we have this one. It says use the first derivative test to find all max and mins and the intervals of increasing and decreasing for the following function. Well, I'm going to go right back to my calculator here because we could do this by hand with the product rule, or you could actually do it with the chain rule, but it's going to get a little complicated. So since I'm doing a new problem, I'm going to just go to Document, File, and create a new document, and then I just say No to Save. And now I can go ahead and save this as f of x. So I'm going to have a negative here. And you want to use this negative button right here to make sure you enter it right. And then I have a fraction, so I'm going to say 18 divided by x squared minus 9. Okay, so I'm going to go ahead and save that as f of x. Okay, so I have that stored as f of x, and now I'm going to take the derivative. So I'm going to go to Menu, Calculus, Derivative. And now I'm going to go ahead. I got 36x over x squared minus 9 quantity squared. And I'm going to go ahead and store that as g of x. All right, we'll write this down later. But I need to figure out where this is equal to 0. Well, you can kind of see it actually, right? Because wherever the numerator is equal to 0, then that's going to be, where you're going to have a max or a min. Since this is the derivative. So it's going to be x equals 0. Now, if you wanted to clarify, or it was not 0 and it was something else, you can just go to solve, figure out where g of x equals 0, comma x, right? And you get x equals 0. Okay, now I want to know the y value for this max or min, so I'm going to go ahead and say f of 0, and that gives me 2. Notice you could actually do this by hand, because if you input 0 here, you would have negative 18 divided by negative 9, which would give you 2. Okay, so at this point, I'm going to record some of this info, and then we're going to talk about what we're going to do here with the denominator, because we have some other things happening in this graph, right, because it's a fraction. So the first thing we have is we know that the derivative is 36x over x squared minus 9 quantity squared. Okay, and then we also know that we have a max or a min at 0, 2. We're not really sure yet. We're going to figure that out as we do the rest of this problem. Okay, so the next thing is that you can't have a 0 in the denominator, right? So when I'm looking at the derivative or the original function, either way, x squared minus 9 cannot be equal to 0, because that creates a vertical asymptote. So I'm just going to solve for x, and we take the square root of both sides. And remember, important to remember, we get two answers. We get plus or minus 3. And what this really means is that this function has a VAs, or vertical asymptotes, at x equals negative 3 and x equals 3. Okay, so we're going to figure out whether this is a max or min in a second. But what we have to do now is consider not just the max or min, we have to consider the vertical asymptotes as well to figure out where the function's increasing and decreasing. So I'm going to go ahead and say x cannot equal negative 3. That's where my VA is, right? And then x equals 0 is a max or a min, and x cannot equal 3. So now what I'm going to do is test values right before and after that. And actually, let's bring this over. Let's bring this over here so we can go ahead and test values and see it on the calculator as we do it. So if I'm thinking about testing values, it can be anything before or after here, right? So I can test -4 here. I'm going to test -2. I'm going to test 2, and I'm going to test 4. Okay, so let's go ahead and do that. We go back to our calculator here, and we already have our derivative saved. Now notice, you could actually do this in your head really quick, right? If you have -4 times 36, well, it doesn't matter what's in the denominator because it gets squared, so it's going to turn positive, right? So if I have a negative number times a negative, it's going to be negative, right? But we can do it in the calculator just to make sure, and we get a negative number. We plug in -2. We also get a negative number. So what that really means is before and after the vertical asymptote, it's decreasing on both sides. And then when we put in 2, we would get a positive number. And when we put in 4, we would get another positive number. Okay, so let's record that info and we can get our final answer here. So we know that the graph is decreasing, decreasing again, and then it's increasing and increasing again. Now, so what does that mean for 0? Well, it goes down and then goes up. So that means actually that 0, 2, our point from earlier, is a minimum. Now, where is f of x increasing? Well, f of x is increasing on 0 to 3. You got to put a break at 3 because at 3 there's a vertical asymptote, right? So it's not doing, the function's not defined at 3. So it's not continuous, so you can't just put 0 to infinity. You got to put 0 to 3 and 3 to infinity. And then what that means is really that x cannot equal 3, and we're leaving that value out of our intervals. So 0 to 3, 3 to infinity, and then decreasing on negative infinity to -3. And then again, we have -3 to 0. And now we've recorded all our information. We found our mins and max. Well, there's only one minimum in this function. And then we've also found our intervals of increasing and decreasing, which is what you can find from the first derivative test.